Okay, so this afternoon we want to look at how to plot graphs, and it's going to be very important for us to be able to do this because most of the mathematical things we have to do, if we are going to make any sense of them, we have to plot graphs, and graphs make it easy for us to see whether the answer we have found or not is correct. But yeah, so we're going to see a simple way using a module called Matplotlib of plotting graphs. So the kind of graphs we're going to look at, if you look at our objectives, you're going to look at line graphs, and also how to change. After making the line graph, we're also going to learn how to change the colors. Sometimes you want a red graph, you want a green graph, you want a blue graph, so how you're going to change the color. Then also we're also going to see how to change the markers, the line markers. Then also how to make plots, line graphs using different types of lines, whether you want a solid line, you want a dashed line and stuff like that. We're also going to see how to put multiple plots on the same paper or figure. Then we're also going to see how to make a scatter plot and how to make multiple plots via subplots. Then apart from that, when you make a graph, sometimes you want to add a title. So we're going to see how to add a title to the graph, and also how to label the axis, whether it's a y-axis and the x-axis. You maybe want to give them a label. And sometimes you want to add a legend, so you're going to see how to do that, and how to add the boxes on the graph. And later on, most importantly, you might need to save your graph. So basically, this is what you have in front of us. Once we're able to do this, then we'll be in a good place. Okay, so just a minute. So this module we want to use, Matplotlib. Now this module is very, very big. What you are going to be using actually is just a small part of it. So there's this module inside Matplotlib which you're going to use. So we're not going to be using the whole thing. Are we clear? For our purposes, we just want to be able to make graphs. But there is much more which this module can do. And for our purposes, we just want to do this bit. So we want to be able to create graphs using just a few lines of code. And also we want to be able to customize those graphs, like adding a title, adding axes, adding labels and stuff like that. There are a bunch of things you can do. Then yeah, so basically that's that. So the first thing we're going to do, this module Matplotlib needs Numpy. So Numpy is very, very important. And we have seen what Numpy can do, and we have looked at Numpy extensively. So the first thing is Numpy, because this module uses Numpy. It understands Numpy. Are we clear? So we need to import Numpy, and we need the Numpy for the arrays. So that's what you're going to do here. So import Numpy as NP. So we're going to import Numpy as NP there. Next, we're going to import this module, Matplotlib. So you import Matplotlib. We're going to use an alias using alias mpl for Matplotlib. So import Matplotlib as mpl like that. So we import Matplotlib as mpl, and next we are going to see what we have access to in this Matplotlib. So there's a bunch of things, as you can see. Like I was saying, Matplotlib is very big. So there's a lot of things you can do. All sorts of things can be done, as you can see from the contents of whatever functions and submodules are in this thing. So there's a lot of things which can be done with Matplotlib. We are going to focus only on one thing, on how to make line plots. That's going to be our focus. How do we make line plots? So as you can see, as I was saying, say there is Numpy also in Matplotlib. There it is, Numpy. There is other things also. For example, there is this one. If you still remember, OS module. We use the OS module for when we're doing stuff about files and everything. The reason being is because your information might be in a file. So there is that stuff also. So there's Numpy inside Matplotlib, and there's other things in there. So what we want to do is, our focus really in this case is we want to focus on a module, a sub-module called PyPlot. So it's inside Matplotlib, but it's called PyPlot. So the next thing we're going to do is this one. We want to focus on this one, PyPlot. I'm looking at this thing here, but I can't see it. But I know it's there somewhere. So we're going to import matplotlib.pyplot. So matplotlib is the name of the module, the main name of the module. Then inside matplotlib, there's another sub-module called pyplot. And that's what we're going to import. We're going to import pyplot as PLT. Okay, so when we do that, we import pyplot as PLT. So going forward, we're just going to use pyplot PLT. Then if you print the contents of pyplot, this is what you have. So also this module comes with its own things. As you can see from this list, a bunch of things which can be done. Basically what kind of plots you can make, so many things. There is a lot, literally, as you can see. We're going to use some of these. Any questions so far?
Nothing.
Okay. So we'll move ahead. So for example, there is certain functions which we're going to need from here. And it's just that there are a lot. For example, there's plot, this one. This is a function we're going to use for plotting our information. Then there's also another one which you're going to see, this one here, show. So this is what you're going to use for showing the graph once we plot it. Then there's other things like subplot. This is another thing we're going to see how to use. Then there's also this one here, legend. This is for adding legends. There's also other things like what? I think title. Title. T here. Title. So we're going to use this for adding titles. There are other things you might need. For example, you want to add something Y label. If you want to customize your graph with a Y label, you could do that. Or if you want to do the same thing with an X label, you could do that. So basically, most of the things which we need for our stuff is we can do our things using this sub-module pyplot. Okay, so let us see the way forward. So the first thing we want to do is we want to set the precision. We want to set the precision to only 2 or 2 decimal places. We want to display all our numbers with 2 decimal places. So basically this is going to display everything to 2 decimal places. Then the next thing we want to do is we want to generate an array of numbers from 0 to 10, and we want to do it in steps of 0.1. So we want to create an array X from 0 to 10 in steps of 1. So that's going to be 0, 0.1, 0.2, 0.3, all the way up to 10. And this array is a Numpy array. So remember, we have imported Numpy, NP. Then if you want to create such an array, there's a function called arrange. So here we've got the starting point, then we've got the finish point, and in between, all the points are supposed to be generated in steps of 0.1. So we create this array, arrange, and that's what Numpy needs. Matplotlib needs. Matplotlib needs arrays of values which we can use for plotting. Then here we print the array which we have generated. So basically this is the array which we have here. So these are the numbers we have generated from 0 all the way up to 10. So this is from 0 all the way up to 10 in steps of 0.1. Okay, if you ask Python what kind of lists or whatever structure you've created with X, so basically it's going to tell you that X is a Numpy array. So using this X, we can create another array Y based on this function. Y is equals to X squared sine X. Y is equals to X squared sine X. This is a mathematical function, but the good thing about arrays is that we can carry out this operation, and for every value of x, we can find the corresponding value of y using this. And since we're using NumPy, so we're going to do the following. We're going to say np dot, I think there's power, np dot power, then x is the array, then we want to raise it to the power 2 times np dot, then we want to access this function here, the sign function, np dot sign, like that. So if you do that, we create an array y, then with creating an array y, we're going to print y, and this is what we get. So these are the corresponding values of y which we get. So we now have, for each value of x, we have a corresponding value of y based on this particular expression. So we've got y values and we've got x values. Using these y values and x values, it's possible now for you to make plots. Very, very possible for you to make plots. So the first thing you have to do, if you're going to make a plot, you need a couple of things. One, you need something you're going to make a plot on, and that's what the figure function is there for. So here, so we start with a PLT. So inside this PLT module, Matplotlib module, we access a function called figure. This figure function is going to create a figure for us. So this is going to create a figure for us. It creates a figure, a plotting figure, to create a plotting figure, to create a plotting figure for us. Then we can plot the values of y as a function of position. We plot each value of y against the position. So the first value against whatever, like that. We can do that. Then here, plot y values, values against index. Plot the y values against index. Then this one here, this one show the plot. Okay, so there are three functions we're using here. The first one is for creating the figure where we're going to plot. The next one here, plt.plot, plot itself is going to make a plot. So it's going to plot this, it's going to plot your x values, your y values against a position. Then after you've made the plot, then you need to show the plot. Are we clear? So you need to create a figure for the plot, then you need to plot the values, then you need to show the plot. Is that clear?
Yes, it is.
Okay, so when we do this with these three functions, when you run, this is what you get. There. You get a very nice plot. You get a plot of your y values on the y-axis plotted against the index on the x-axis, the position. So we have generated 100 values. As you can see, 100 values here, more than 100 I think. Yeah, 100 values this side on the x-axis. So you're plotting against the first value, the second value, like that for each value of y. And this is what our function y looks like. So as you can see, it's very, very straightforward to make a plot with Matplotlib. You just need a figure function. So you access the figure function. The figure function will create the plotting figure. The plot function will plot the values. So in this case, since you've just given it one array, it's plotting those values of y against the index. Then you need the show function. The show function is going to plot, is going to show, not show, it's going to show the plotted values. Okay. Now, however, usually what you want to do is not to plot against position. What you want to do usually is to plot against other values. For example, in our case, we have got x and y. So here, again here, so we create a plot figure. Then next here, plot values of x against y, then here show the plot. So usually this is what you're going to be doing. We'll plot x against y. So you give two arrays. one for your x values and y for your y values. When you do this and you make a plot, then you run it, this is what you get. Same. But now at the bottom here, things have changed. So this side, the y values are the same. It's 2 minus 60 to 60, but at the bottom here it has changed. It's now 0 to 10. Previously, when you just made a plot of y, it ran from 0 to 100. The reason why it did that is because you were plotting against the index. So if you just give y, say plot y, then it's going to plot y values against the index, against the position in the array. Are we clear? The difference on the difference? Is the difference
Yes.
the difference clear on what has happened?
Yeah.
Okay, so basically,
Yes.
in a nutshell, this is how we are going to be plotting things. When you use plot, this is a kind of graph you get. You get a line. This is what is called a line plot. The plot function gives you a line plot. Okay. Next, we can change the colors. We are not restricted to this blue which we have here. We can actually change the colors. So here, inside the plot function, we give plot the array x, the array y, but we can also specify what kind of color we want to use. Are we clear? We can specify what kind of color we want to use by setting a keyword argument called color. So in this case, if we want the color to be blue, so we're going to say first figure. We have seen what figure does here. It's going to create the plot. Then we want to plot x and y, but we want a blue line. Then we want to show the plot. So here, this is how we set the color. Say color set to some particular string. So this b here, this string b is for blue. So when you do that, this is what you get. So you can see the blue which we have and this one, this which we have here, they're a bit different. So this is I think this is gray or something. This is the default one. Yeah. But you can see if you set it to blue, that's what you get. So the color of the graph changes like that. So that is if you want a graph with a blue color. You can set the color to green also. Here we say color set to green. So you put G there. When you do that, when you run it, then you get a graph which has got a green line there. Are we clear? So it's possible for you. Yeah, it's possible for you to change the colors of the graph. You can also set the color to red here. Color to red. So the red is R. So we run that. You end up with a red line. There. You can also set the color to crayon with C. So if you run this, this is what you get. You get that color. Then there's a color called magenta. You set it with M, a string M, this one. So if you run it, that's what you get. Okay. Next, you can also set the color to yellow. So we set it yellow with this Y. So if you run it, that's what you get. You can set the color to black. We set it black with K. You run your graph. That's what you have. So basically, there are a bunch of colors you can set your graph to. Are we clear? It depends on what you want. If you want a red one, if you want a blue one, if you want a black one, there are certain color schemes you can use. And that's how you set the color, by adding the color keyword argument, then giving it a particular value. Okay. Any question on how we set colors?
I'm just on setting colors. I think I'm clear.
Okay. Why are you not clear?
A bit behind on how we got the values of y from x. Hello? I'm saying for the color thing, I'm clear. I'm just wondering, I'm just a bit lost on how we got the values of y when we had the values of x.
From here. This expression, we created this. We created this expression. Does this make sense to you?
Yes.
You understand how we got the values of y?
Yes.
We're following this. X to the power 2 multiplied by sine p. But this power function is found in Numpy. Numpy has got a power function, then also Numpy has got a sine function. And the reason why we have to use Numpy is because what we have for x is a series of values. It's an array. So if you want to use arrays, then you have to go to Numpy. We created the array using Numpy, so we have to go and access the array versions of the power function and also the array versions of the sine function from Numpy. Okay? Is that clear?
Yes.
Okay, next.
It is clear.
The next thing we can do is you can also change the markers. Where are the points? Okay, by using a parameter called marker. For example, we're going to stick with the same color, so we'll maintain the color. The color of the line will be red, but what we want to use is now we want to use a solid line with markers which are dots. So if we do that, so you set marker to that, so we have this. So where the points are, this is where with these dots, these red dots here. Can you see the dots?
Yes.
Yeah, so that's how you specify what kind of marker you want to use to specify a point on a graph, like that. So if you want solid circles, that's what you can do. If you want to use actual circles, you can use this one also as a marker. When you do that, then this is what you get. So now these ones are different. You can see these ones are smaller, these markers are smaller, but if you use O as a marker, you get bigger circles. This. Okay. The other thing you could do is you could use markers which are triangles. So this one is used for lower triangles which are pointing down, V. So we use V for triangles which are pointing down. So if you do that, you could have markers which are like this, triangles which are pointing down. So you specify that kind of marker with a V. Okay. You could also specify markers, triangles which are pointing up by using this symbol, which is a caret. That's a symbol on top of 6 on the keyboard. So on top of 6, there is that. So if you do that, then you would have your markers which are like that. Okay, there. The other kind of markers are these ones, left triangles. You can use a left triangle. So a triangle which is pointing left. So which are these? We're using the less than sign. So with your left triangle markers, using the less than sign, or you can have your, of course, you can have your right angle triangles by using the greater than sign. So if you use the greater than sign, you could have that. Are we clear on the markers?
Very clear.
So that's something you can. This is something. Today we're just talking about graphs. What you can do with a graph? How do you plot your things? Then how can you change the line, the color of your line? How can you change the markers? like that. So basically these are some of the customizations you can make. You can choose to have square markers. So you use S for square. If you do that, then you end up having markers which are squared like this. Yeah, that's what, if you choose to have square markers like that, so you can do that. Then you can also choose to have markers which are pentagons. So you set the marker to P, right? Then you have markers which are pentagons like those. So there's basically, you have a lot of choice. You can have a marker which is, if you want markers which are stars, you can do that. That's also possible. There, markers which are stars, like that. So if that's what we want. You can also have markers which are hexagons. Those ones here. Those are hexagons. And so there's another type of hexagon with capital H, but similar. So the point is the hexagons. You can also use a plus sign as a marker. Use a plus sign, so that's what it's going to be, plus, 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 like that. You can also use a multiplication sign as a marker. Use a multiplication sign. That's what sometimes people do when they're making a graph here, like that. Then what else can you do? You can use a diamond with capital D. So you can use diamonds. But, and there's another one, a way of using a diamond with small d. You can do that. Okay, you can use lines, a vertical line for a marker. That's one way of doing things. You can do that. But as you can see, things are not very clear somewhere else. Or you can use something like this for a marker. That. But it's not clear in some other parts. It's clear somewhere else, but some other parts it's not. Okay, so basically, that's on the markers. There is also a lot of choice. Apart from the colors you have to choose from, you probably need some markers. There is also a lot of choice on the markers. Are we clear?
Yes.
Yeah. Now, so far we have been using only one type of line, but there is also choice in the kind of lines you can use for your graph. You can have different types of lines. For example, the one we have been using, the line we have been using is a solid line. Okay, so how do you denote a solid line? It's just by doing this, by using a hyphen. So you specify the line style. Okay, so if you want to change the line, you have to specify line style. If you want to add a marker, then you say marker, but you're keeping the color to be red. Okay, you keep the color to be red. Then if you want to change what kind of line you want to use, you have to specify the line style. So there are a couple of ways of doing that. If you want a solid line, you just do this. You give line style a hyphen. If you give line style a hyphen, then this is what you get, which is what we had before. Okay, red and a solid line. If you want to change the line from solid to dashed, then you give it 2 hyphens like this. Line style, you set it to 2 hyphens. If you set line style to 2 hyphens, then you end up with a dotted line like this. Are we clear?
It's clear.
Yeah. If you want to have a dashed and dot line, so you put a hyphen and a dot like that. So you're going to have a dashed and dot line. So you end up having this kind of a line. Dash dot like that. So you also have a choice, a lot of choice on what kind of line you want. Okay, so you can change the color, you can change the markers, you can also change the type of line. Three things you can change. You can change the color, you can change the marker, you can change the type of line. If you want a completely dotted line, if you just want a dotted line, then you have to use this. You have to use a colon. Like that. Colon for line style. When you do that, then this is what you get. So you get a dotted line like that. Are we clear?
Yes.
Okay. Sometimes you want to have, like what we have here, we only have one line on a plot. Sometimes you want to use the same figure, then you want to plot more than one plot there. Okay? So if you want to do that, if you want to make more than one plot, it's possible. The only thing you need are multiple plot functions. Because remember, if you're going to make a plot, you need to use a plot function. Okay? So if you want to make more than one plot, then you need more than one plot function. Okay. Yeah, I think the other one, I need to remove it. Okay. So if you're going to make more than one plot, you need a plot function. So in this case, we want to create another array, W. So this W is going to be based on this function. W is equals to x squared cos x. The other one we had is x squared sine x. Remember? The y we were plotting with y is equals to x squared sine x. So what we want to create here is another array, W equals to x squared cos x. So when you create this array, we want x to the power 2. So that's what we have here. We're using the array version of power, np.power x to the power 2 multiplied by the cosine function, which is found in the numpy module. So np.cos x. When we do that, that's how we create our W. Okay. Okay. I thought there was a mistake, Can you see the screen?
Yes.
Yeah. So I was saying that it's also possible for you to have more than one plot on a figure. Okay? It's possible for you to have more than one plot on a figure as long as you use multiple plot functions. So you need to call plot a couple of times depending on how many things you want to make a plot. So in this case, we want to create an array W which is equals to x squared cos x, like this. So in this case, what you're going to have is we have this bit we know how to do, x squared, so that's going to be np.power then x to the power 2, which is what you have here, np.power x to the power 2 multiplied by np.cos x multiplied by this bit, np.cos x. That's what we have here. So next, if we run this, okay, then we print W. We print W. So this is what we have. This is our W. Okay. Now we want to plot these two functions, y and W, on the same figure but using two different plots. So what you're going to do here is here we create a figure we're going to use. So this bit here is going to create a figure. So you create a figure which you're going to use. Then this one here, this function here, POT.plot XY, color red line is dashed. This is going to plot X against Y. This other one here, the next plot function, POT.plot XW, blue line style dotted, this is going to plot X against W. Then we're going to show. So basically, this is a very simple way of you plotting more than one line on a graph. You just use multiple plot functions. Are we clear? You need one figure function,
Yes.
multiple plot functions, then you can show. So when you do this, this is what we end up with. There. So we have one which is red. The red one is the x squared sine theta. This is how x squared sine theta is changing. This is a graph for x squared sine theta, like that. The other one is the blue one, is the x squared cos theta. There, like that. Now, this shows you something very important about this piece of software, this module, Matplotlib, PyPlot. Very quickly, you can see how functions are different. You can see what a function looks like and how it's behaving with time. Are we clear? It didn't take us a lot of it didn't take us a lot of time to organize graph paper and everything. No, we have just produced things quickly like that. So it's very convenient, and it's very easy for you to use. So that is how you would put more than one plot on a figure if you wanted to do something like this. Are we clear?
Yes, it is clear.
Yes. Next, you might want to create something which is called a scatter plot. Sometimes you just want to, you don't want a line, but you just want to plot the points. Okay, so if you want to create a scatter plot, then there's a function called scatter. That's what you're going to use. So of course, the first thing is you have to create a figure. Then you use this function called scatter. Then you give it the arrays you want to plot. Then you show. Now a scatter plot basically looks like this. So this is what a scatter plot is. This. So you just plot the points without joining the points. Are we clear?
It's clear.
Okay. Next, so that's for a scatter plot. So if you want to do something like that, then that's what you have to use a scatter instead. So you can use, if you want to use make a line plot, you use plot. If you want to just plot the points to show the points where they are, then you use scatter. Okay. Now, sometimes you want to divide your figure into small boxes so that each plot can go somewhere. Okay. In such a case, if you intend to divide your figure into these smaller boxes, into these smaller plots, so that each plot goes into a separate box of its own, then you have to use a function called subplot. Now, this function called subplot requires a couple of information. It requires to know, it needs to know how many rows you're going to divide your plot into, and also how many columns you're going to divide your plot into. So it needs to know the number of rows, it needs to know the number of columns, and also it needs to know which subplot figure are you using. So these subplot figures have got numbers, so you need to specify that. Okay, so what you're going to do here is, first of all, as I'm going to show you, we create a figure. So we create a figure. So PLT.figure. So this is going to create a figure. So create a figure. Create a figure. So create a figure. Create plot figure. Create a plot figure. Next, this figure we've created, we use the subplot function to divide it into 2 rows and 2 columns. So if you imagine you've got a square, then you divide it into 2 rows and 2 columns, then you end up having 4 boxes. Is that clear?
Yes.
So after we divide this thing into 2 rows and 2 columns, we use the first box. Okay, we use the first box, and in this first box we plot our XY using a red line. Then next we move on to we activate the second box using this number here. So it's 2 rows, 2 columns in the second box. We plot using the magnetar. The next we activate the third box here, subplot 2, 2, 3. So the first 2 is the number of rows, then the second 2 is the number of columns, then the third 2 is the index of the figure we're creating. This one we're going to plot using blue. Then the last one we activate and you're going to plot using black. So in that case, then after that we show what you've done. When you do that, this is what we end up with. So the first one is this one. The first figure is this one, the one which has been plotted with red color. This is the first subplot. The second subplot is this one, which has been plotted with magnetar. Second subplot. The third subplot is this one. It has been plotted in blue. And the fourth subplot is this one, which is black with dotted lines. So this is what is referred to as a subplot, where you divide your plots, your figure, into these small plots. Then you, in each separate plot, you put something there. Is it clear what we've done and how we've done it? So we start with creating. We start by creating a figure, PHY.figure. Then next, the first time we use subplot, we specify how many number of, what's the number of rows and what's the number of columns we want to divide our figure into. Then we activate the first figure. Now in the first figure, that's where we want to plot this. That's where we're plotting this, the red one. Are we clear? After we divide this thing into 4, so in the first figure, that's where we put this one. Then again, this line is used for activating the second figure, which is this one here. Then this is where we plot this. Then the third one, this third subplot function, we use it for activating the third figure, and that's where we put our next plot function. Then the fourth one, we activate our fourth subplot figure. That's where we put these. If we did not have the subplot functions, if I do the following, if I comment out, are you still there? Hello?
I'm there.
Yeah, if I don't have subplot, if I remove the subplot functions, I comment them out like this. What you're going to have is just one figure, and all the plots are going to be put in this one figure. So if you run this, if I comment out that, what you're going to have is this. You see, all the different plots have been squashed together like that. We end up with something like that, which is not what you want. What we want to show is how do you divide a figure into smaller plots, and each of these smaller plots ends up, it's like you've got a piece of land, then you subdivide it into smaller plots. Basically, that's exactly what you've done here, and that's what we do with subplot. Are we clear?
Yes.
Yes. So I undo the comments, and we end up with this. Any questions so far?
So far so good.
All right. There are other things, of course, which you can do. For example, you can add a title to your graph, and that's what you're going to do. You can add titles, you can add axis labels, you can also add legends. So the next things we're going to do is how to add a title. So in this case, how do you add a title? You add a title using this function, the title function, PHY.title. That's what you use for adding a title. So we start with here. You create a figure. So PHY.figure, you create a figure. Then this here, you plot your things. So the red line with dash dotted. Then how do you add a title? So you start here, PHY.title. Then of course, here, label. What's going to be the title? My first titled line plot. Then maybe what's the location? You can put left, that's fine, or you can put center, that's also fine. Yeah, left. If you want the title to be on the left side, that's okay. So this is the location here. This is for location, and this is the label or the name of your title. Right. So if you do that, that's what you get. So you get my first here, my first titled line plot. So there you've added your title to your plot. Are we clear? But it's on the left, if that's what you want.
Yes.
Yeah. Next, you can also add a title to the center. So if you want to change the location from left to center, so you put center there. Then if you plot it, this is what you end up. So the title is going to be here on the center here, like that. Next bit is if you want the title on the right, so you say location right, then you do that, then your title is going to be on the right side. Are we clear on how you add the title?
Very clear.
Okay. The next bit is you can add axis. Right now, along the y-axis, along the x-axis, there's nothing you've put there, but you can always put something there. So, and how do you do that? By using a function called xlabel. So this xlabel function, you use it for adding some label along the x-axis, and the ylabel function, you use it for adding some label along the y-axis. So in this case, here we create a plot, a figure. We create a figure, then we make our plot. XY, color is red, line style is that. Next, we add a title with a label, title plot. Then of course we want to use a center. Then this is how you would add your X. If you want your X to look mathematical, you can put some dollar signs. So we'll see what putting a dollar sign does and what it doesn't do. And inside you can say what the units are. So we start with here. We can start with not adding dollar signs. We can just say X. So you can see what the difference is. We can just do this. So here, it's actually possible to not add it in dollar signs. So you get your Y, then you get your X in radians like that. Are we clear?
Clear.
Sometimes you can also add some dollar signs. If you add the dollar signs, I'll do a copy of this. I'll add the dollar signs on the X. Is it on the X on the radians? Let me see. Let me try to add them on the radians. Let me see what happens. Maybe it will become more prominent. Yeah, so if you add the dollar signs on the radians, you can see the radians become italics. Let me see rad. Yeah. So sometimes, yeah, so basically, yeah, you can always add. It's not a must, but certain things look better when you add the dollar sign, as you're going to see, especially with legends. Okay. So that's what. So that's how you can add things. Then comes what's referred to as a legend. Now this will get we need a bit of getting used to, but if you want to add a legend, there are a couple of things you can add to your plot function. For example, there is a function, there is a label, there is a keyword argument called label here, and this label we have here, this is a label equals to x squared. Then this whole thing which I have inside here, I'll show what it does. Or we can just say this is what. We can just say that is y, I think. Then this whole thing here, we can just say this is w, just to make things less complicated. Then of course in here we have our rad. Then I'll remove the dollar signs here. Yeah. So if you want to add a label, so this is what you have here. That and this. But I think it will be y is equals to, let me do this, x squared, then sin x just a minute. Then this one here, x squared cos x. Okay, then you have to use this bit here. If you want to add a legend, you have to use this PLT legend. Then it comes to location, you set it to based, then it's going to choose which one is the best location to add a legend. Then you do a show. Then when you do that, then this is what you're going to end up having. This. So this is what is referred to as a legend, this box here. So this box explains exactly which one is which. You've got y is equals to x squared sin x, and w is equals to x squared cos x. So you can see, people can quickly see which plot is which adds more information to your plot. Are we clear?
Clear.
Okay. Next. So there is that way of adding a legend. There is another way of adding a legend. Another way of adding, so the first way of adding a legend, we used, if you notice, we used this inside plot. Inside plot, we used label like that. For each plot, we provided a label. So this plot is supposed to be this, that's supposed to be that. Then there's another way of doing things, which is not, I don't think I would advise, because it assumes things, you have done things correctly. So in this case, you just say plot, the first plot, the second plot, you don't add a label, but then you provide your labels as a list inside legend here. POT.legend, then you provide your labels as a list. So the first list item is a legend, is going to be used as legend for this plot. Then the second list item is going to be used as a legend for the second plot. So here you're providing a list of your legends. So this is another way of doing things. I think this might be better, in my opinion. So just do your plots, and you provide the list of legends. Then of course you specify the location to be based, and if you do that, this is again what you get. There. So the two of them are indistinguishable, but the way you have added the legend is different. Here, this is what you use. The previous one you used label, but here you provide the legends as a list. Are we clear?
It's clear.
Yeah. So if you need to add more stuff on what this is, what that is, things can be done like that. So that's a very good way of doing things. Last but not least, since you will be doing graphs also, sometimes it will be very, very important you add a grid. Now for you to add a grid, there's a way of doing it. You just use a grid function. This. Basically, that's the boxes. You want to add the box lines, the boxes to your graph, so that it looks like things have been done nicely. So you use this to add a grid. So when you add this grid function, then it will add something. So here we create a figure, we add a title, we make a plot of x, y, plot of w, we add a label, x label, radians, then we add a legend, then we add a grid, then show. When you do this with grid, this is what you end up having. So grid adds these boxes to your graph like that. So your graph will probably look much neater. That's what grid does. It adds these lines. Are we clear?
It's clear.
Okay. Now that I think we are happy with what our graph looks like, it's usually a good opportunity to save it. So once you're happy with your graph, then you can save your graph. So you can save your graph. So in this case, for you to save your graph, you have to use the save figure function. So there's a function called save figure. So use that to save your thing. So you do the save figure before you show your plot. So you run save figure before you show the plot. So in this case, you have y is equals to that, w is equal to this. So we create a figure, we add a title, we plot y, we plot w, we add x label, add x, you add a legend, then you add a grid, you save a figure. So here I'll say my titled simple line plot, simple line plot, like that. So you have to give the name of the file, how you want to save it. So this is going to be saved as a JPG. Sometimes people try to save things as PDFs, but JPG is also fine. Then you show your thing, whatever it is you have done. So like that. Okay, then you run this. When you run that, so yeah, we'll be shown our plot. This is our plot here. But so remember, the point is to have it saved somewhere. So I'll check where I keep my things. Where is it? See if it has been saved. Okay. So now it's a matter of looking. My M. Where is M? Oh, here. My title is simple line plot. So I open that. So there it is. I can maximize there. So you can see the plot we have created, we have done everything, and we have also saved it. So basically that's what I wanted to show you. Can you see?
Yes.
Yeah. Okay. All right. So I will, unless you've got any questions.
No, I'm very clear on this one.
You're very clear on this one. That's good. Okay. So we have to meet tomorrow. Are you available? Are you available?
Tomorrow? Yes.
Okay. So I have got doubts on which bits, whether I start the course tomorrow, the actual numerical thing tomorrow, or I start it next week. If we don't start it tomorrow, then there has to be something which I need to teach. The question is what? There is a module called Symbolic Python. So probably I can walk you through that module, because it's also going to be important for some of the things which you need to do, and also for you checking on your own if you've got the right answers or not. Okay, so I'll try to see what I can do, how much work I can do in the morning, because right now we are done here. I will need to go back marking certain things. Then tomorrow morning I'll need to sit down and try to prepare for the class in the afternoon. I'll let you know if I manage. If I don't manage, then I'll tell you ahead of time.
All right.
The other is remember I asked you for a date during the middle of the week. I have got Wednesday afternoon.
Wednesday afternoon?
What are you doing on Wednesday afternoon?
Okay, maybe we can start after next week, because next week I'm a bit held up during the week. So if we can start the other week, then in fact by that time I'll even be in Lusaka for practicals for the other courses. So we can start after next week for the week.
During the week?
Yes.
Okay. So Wednesday. Okay. So let's keep Wednesday after. Let's reserve Wednesday afternoon.
All right.
Yeah. So see you tomorrow.
All right.
Yeah. Keep your Saturday, Sunday, and Wednesdays. Try to keep them clear so that we can do things, because one way or another we have to. This is basically, as far if you wanted, we could make it the end of the Python, but there's something which I don't know. Maybe it might be useful.
Okay.
I've got a feeling it will be useful. Yes. Yeah. Okay. So.
Then no problem. We can do it.
All right. So we end here. So see you tomorrow.
All right. Thank you so much. See you tomorrow.
Cheers.
Cheers.
Okay.